What did scientists do? What the dire wolf, Enochion, an apex predator of the Pleistocene epoch, once dominated the vast landscapes of the Americas, from the frozen tundras of Alaska to the subtropical grasslands of Mexico, thriving alongside megafauna like mammoths, giant ground sloths, and Smilodon. These robust canids, larger and more heavily built than modern gray wolves, played a critical role as ecosystem engineers, shaping prey populations and maintaining ecological equilibrium. Yet, as the last ice age waned roughly 13,000 years ago, a confluence of climate upheaval, shifting habitats, and human encroachment precipitated their abrupt disappearance, leaving behind a fossil record rich in intrigue but sparse in genetic material. Today, the dire wolf's story is being rewritten through an audacious fusion of paleogenomics and biotechnology. Scientists, armed with fragments of DNA extracted from permafrost-preserved remains and tar pit specimens, are employing CRISPR-Cas9 gene editing to splice ancient code into the genomes of their closest living relatives, such as the gray wolf and coyote. This process, fraught with challenges like DNA degradation and hybrid viability, is bolstered by synthetic biology techniques that fill in genetic gaps using predictive algorithms modeled on evolutionary patterns. The project, spearheaded by a coalition of geneticists, ecologists, and conservationists, aims not merely to resurrect a species but to probe deeper questions. Could reintroducing dire wolves help rebalance ecosystems degraded by the loss of large predators? Might their return curb overgrazing by herbivores or even mitigate carbon release from thawing permafrost? Critics, however, warn of unforeseen consequences: potential competition with extant wolves, disease risks, or disruptions to human communities, while ethicists debate the morality of playing God with evolutionary timelines. Proponents counter that the endeavor symbolizes a paradigm shift in conservation, where technology serves as a tool for atonement in an age of anthropogenic extinction. As the first genetically reconstructed dire wolves undergo controlled reintroduction in isolated reserves, their progress is meticulously monitored via GPS collars and environmental DNA sampling. This unprecedented experiment, straddling the line between ambition and hubris, invites us to reimagine humanity's relationship with nature. Are we witnessing the dawn of a new conservation era, or merely a high-stakes homage to a lost world? The dire wolf's resurrection, steeped in both scientific ingenuity and existential reflection, challenges us to confront our past and renegotiate our future in an ever-changing biosphere. Guess which species will scientists bring to life next? Don't forget to comment and subscribe.